Okay, so we'll talk about, pick up our conversation on classes. We'll talk about inheritance now. So inheritance is, it's a good thing in that if somebody else already wrote a class for us, we can create a new class and take all the information and methods from that class. We don't have to rewrite them when we're creating a new class, and then we can add stuff on top of that. So generally, when we inherit from a class, we're going to use the class we had last lecture called circle, and we're going to make a special type of circle. And this isn't the greatest example in the world, but we're going to call it a graphic circle. So that's a circle where we can actually pick a color for the circle, and we can pick a color for what's inside the circle. So what we're going to do is, now the circle had an x coordinate, a y coordinate, and a radius, x, y, and r, we had last class. So when we say our new class, called graphic circle, extends circle, we're going to get the x, the y, and the r automatically. We don't have to declare it again. We don't have to say double x, double y, double r. It's like we got it for free. We can add stuff on top of that if we want to. So we're going to add two new variables, and the type is going to be color. Now, color is not a primitive type. This is something you haven't seen before. So we're making an assumption. Somebody defined a class called color, which has all the different choices, and red, green, whatever color you want. Now we're going to have two more variables, one called outline and one called fill, and they're going to be of type of color. So the outline of the circle, like for example, if the circle had an outline of green and a color of red, it would be like this. That would be like a graphic circle. Right? The outline would be one color, and what's on the inside would be another color. We still have an x, a y, and an r, but rather than creating a brand new class and having double x, double y, double r, we're just going to extend circle. So we'll get all that stuff for free. If down the road somebody changed the definition of a circle, which I doubt is going to happen, but if somebody went and changed the definition of a circle, we wouldn't have to make our change in two places. We wouldn't have to change our circle class, and we wouldn't have to change our graphic circle class. We just make the change in one place, circle, and then this will inherit or pick up all the new changes next time we compile. Okay. So now if we create an object of type graphic circle, we have the concept of now the constructors. What would happen if we decided later on to, somewhere else in our code, if we said graphic circle, graphic circle GC equals new graphic circle. Right? This, what's in green is somewhere in some other code. We're now trying to create an object called graphic GC. It's going to be GC, and in here is going to be the definition of a graphic circle. We get a chunk of storage. How many fields are going to be in the chunk of storage? Based on the way this is defined. So we have the three fields that came with circle, the x, the y, and the r. We've added two additional fields to it, an outline and a fill. So those will be in here. We'll have the x, the y, the r, and now we're going to have a fill and an outline. So it's an object with 5 fields in it. What do these fields get initialized to? Now remember what we talked about last class. We said that a constructor is a function that we can run when we're constructing an object, and we can fill in these fields. And in fact, we had a couple of constructors, right, last time? We had the one where you give all 3 parameters, and then we had one where just the radius, right? So the x and the y by default became 0, and we just filled in the radius. So we actually had 2 constructors last time. But now, it looks like the way we define this class, we don't have a constructor yet. So what happens if you don't have a constructor? Is this not allowed, or is there some default constructing thing that happens? Or if you were designing a language, what would you do? Would you require constructors for every class that you make? Or would it be optional, and you could use the idea that just fill in all the fields with default values if the programmer didn't give us a constructor? So I think we had two different answers last class, right? We were saying, you know, we can make it a compiler error, you know, you have to have a constructor, or you can just fill in the fields with default data. So let's try to put a constructor together for this class. Let's open up this class. What now would be the inputs to the constructor? Well, first of all, what's the name of the constructor? So the constructor is a method that is called whenever you create a new object, and it's called implicitly. You don't actually say its name. You just, by declaring the object, by creating the object, you automatically call this function. It's an opportunity for us to fill in the fields with whatever data we'd like. So, like for example, if for the circle, if we didn't give a constructor, they could fill in the x coordinate with a default of 0, a y coordinate with a default of 0, and then a radius with a default of 0. And, well, what good is a circle with a radius of 0? It's a point, it's not even a circle. So we decided that we wanted, by default, the radius should be 1. But because the field is a double, the computer doesn't know it's a radius, it just knows it's a double, so it will by default put in a 0. So we would like to change the defaults to x is 0, y is 0, and radius is 1. So we wrote a constructor for our circle class that said the radius should be 1. So actually we wrote two constructors. We wrote one where you pass in the x, the y, and the r, and we fill them in. And another one where you just pass in the r, and you fill them in. And then we could have written a third one that takes in no parameters, and then we just create our own. I think we did that at the end of the class. We wrote one that takes in no parameters, and it fills in x is 0, y is 0, and r is 1. So now, we want to create a graphic circle. So let's write a constructor for this class. Let's first of all write a default constructor. What would the default constructor do? So a default constructor would be a public method. The name of the method is the name of the class. That's how we know it's the constructor. Right? So it'd be graphic circle. That way we know it's a constructor method. The default one is the one that takes in no parameters. That's if you just say, I want one of these, and you don't give any information. So the default one takes in no parameters. And what does it do? Okay, well, what's a default value for an outline? I guess we can make this up. And what's the default value for the fill? For a circle. The outline is black, I guess, and the fill is white? Okay. So the default constructor will be, okay, now, what should the x and the y and the r be? Should we, well, here, all right, so why don't we do this? Why don't we say, we'll write it out explicitly. We'll say, using this. But actually we don't have it. So we could say x equals 0, y equals 0, r equals 1, outline equals black, fill equals white. And we have now just defined a default circle. So if somebody ever did had before, graphic circle. Equal, graphic circle, GC equals new. And then they said graphic circle and ended it with no parameters. This method will be called automatically. Since we have gotten the fields X, Y, and R from circle, even though we don't see them here, they're there. The new fields that we've added are the outline and the fill, and now we've filled in all the fields with default values. But there might be a little waste here, because last class we said we already have a method that does this, right? In the circle class, we have a constructor that does exactly this, right? So now we would have these 3 lines and the same 3 lines in the circle class. They would be exactly the same. Suppose we decided later on we're changing our definition of a default circle. For some reason we decided a default circle is radius 2. We would have to go to both places and change this, right? Wouldn't it be nicer if we could, instead of explicitly saying these 3 lines, wouldn't it be nice if right here we could just call the constructor of a circle? So, and then the advantage to that is if we ever change the constructor of a circle, we would just automatically pick up the change here. We don't have to make the change in 2 spots. So how would you, if you were designing the language, you'd want to have a line right here that says call the constructor of not graphic circle, but the constructor of circle. How would you explicitly call that?
This dot circle?
What's that?
This dot circle?
Circle. This dot circle. And the one with no parameters. Would that work? I think. Wait, this.
Or maybe this dot, whatever the
This
parameter
would
is.
be the graphic circle.
I would say circle GC music.
Let's just think about this. I like this suggestion, but this looks like we're calling the circle method of this object, and this object is the graphic circle. So it's like saying the graphic circle has a method called circle, which it does because we've inherited all the methods from the previous class. But yeah, actually, there'd be no ambiguity. I know exactly what you're doing.
I didn't mean to say it like that. I really meant this dot radius and this dot.
Okay, so like this dot x equal.
Yeah.
Okay, but that would be almost what we had before. This x equals 0, this y equals 0, and this r equals 1.
Yeah.
Okay, so just on the concept of this, it means for the object, when you have a method that is tied to a class, I'm sorry, tied to an object, every time we go to create an object, the method applies to the object. It's not a static method, meaning it applies one for the whole class. It applies to a particular object. So this reference means the object it was called for. And that helped us last class because we passed in parameters like x, y, and r, which were global parameters coming in, and then we had our own x, y, and r. So to avoid the confusion, we use this x equals x, this y equals y. So we get for free, THIS is a keyword in Java, same in C++, that refers to the object that this method was called on. So this this x and x are actually the same thing because there's no other x field for it to be confused with. But what we want to do here is we want to take these 3 lines, since they are what we're calling a default circle. This part was added for the graphic circle, but the default circle had an x, a y, and an r, which got filled in with default values. So if we wanted to call, at this point, we want to call the constructor for circle. See, we're in the middle of the constructor for graphic circle, but one step we'd like to do is call the constructor for circle, which was there from before. So the way you had it written out, that wouldn't compile, but it actually gets the point because we are inheriting a method called circle, which is the constructor for a circle, and you were trying to call it. So you would think that could compile, but it turns out it doesn't. But what we want to do is we want to call the constructor for the class we inherited from. So we're inheriting from, we have the class circle, and we inherited graphic circle from that. So in this class, there's a method called, actually there was a bunch of methods called circle. The construct, we had one with no parameters and one with 3 parameters and one with 1 parameter. So we had 3 different functions called circle in here. And now we're in this class, and we would like to actually call the function that's up here. Now, like, what was the other function we had in this class? We had a function called area, right? And it told us what the area of the circle was. We could call, on graphic circle, we could call the area function, and it will, since we don't have an area function here, it'll just take the one we inherited and it'll call that one. So that would work fine. Could we now explicitly call the constructor of circle by calling it by name? In other words, could we do this? Could we say, yeah, actually, the way you originally said it was this circle with no parameters. This kind of gets the idea across what we're trying to do. We're trying to take the object we are now in the process of creating, calling its circle method with no parameters. And circle we inherited from the circle class. So this wouldn't compile, but this is the idea of what we're trying to do. Was there a question?
So it shouldn't be a double before this, or I don't know.
A double?
Comparing it, a double.
A double where?
Before this dot circle. Yeah.
Like we're returning a double?
Or int, depending on where it was.
Like, okay, like this?
Yeah, not.
Double circle. Circle. Something like that?
Yeah.
So that's really, what we're doing here is we're saying that this is, we're defining the function and saying it, when it's done, it returns a double. But right now, we're actually, so that's when you're defining a function. When we're calling it, like if we were calling it, we want to have like a double, you know, like A equals, and then A would be defined as.
Okay, yeah.
Right, okay. But actually, so for constructors, you would think they have a return type because they actually, when they're done, they're returning an object of this type. So you would think its return type would be graphic circle. Because what we end up doing is we create a brand new graphic circle, we fill it in with initialized data, and then we return it. But because it's understood that the type that's being returned is the same as the type of the function, you don't have to write that's the one function you're allowed to leave that out of. But what we're trying to do here for the first step of our graphic circle constructor is we want to call the constructor of the previous class, because they already did the work for us. So, like I say, one thing we could have done, we could have wrote it out explicitly, x equals y equals r equals. But now we have the same thing written in 2 places. And if we wanted to change it, then we have to remember to change it in 2 places. It would be better if we could just, right now, from right here, call the constructor of the class we're inheriting from. If we're in this class, we'd like to call the constructor of this one first, and then we'll do this extra stuff. So this syntax, which you suggested, looks pretty good, but they don't allow it. This object circle with no parameters. Right? We're taking the object we're currently creating, It should have a method called circle, because we're inheriting all the methods from here. Now, we had 3 constructors here, we should inherit all 3 of them. That method should be allowed. But they decided to use a different syntax. Any other suggestions you can make for saying, in the class I'm currently in, I'd like to call the class above me's constructor. And they call the class that's above you as your superclass. So graphic circle has a superclass of circle. By definition, it's called a superclass. So maybe that's a little bit of a hint, but it's not a great hint. What we can do here is we can say super. Super with no parameters. Actually, I like your method better. I like this dot and then explicitly say the name. But then we would get into the situation where if we inherited from a bunch of things, if there was a big trail, then we could start calling them by name, and they don't want that. They only want your class to call the class just above you. It's the responsibility of this class to call the class just above it, and so on. They don't want the guy at the bottom jumping all around and getting things out of order. What they always want in Java is the very first thing your constructor does when you inherit. The very first thing the constructor should do is always call the constructor of the class above you. Should always be the first thing. If you left this out, if you just forgot to do it and left this as your constructor, all we're doing is filling in the 2 new fields and leaving the 3 fields that we inherited, the X, the Y, the R, leaving them alone. By default, this line gets written in whether you put it there or not. Super. That line gets automatically put into your constructor, whether you put it there or not. So the very first line of your program should be a call to the constructor of what you're inheriting from. So if you have a class that inherits, when you go to write constructor functions, so those would be functions with the same name as the class, constructor functions, which get called implicitly when you go to create an object. If you don't say the very first line of your constructor method, if it does not call the constructor of the class above you, this line will get put in automatically. So now you might think, well, why did they even let us do that? Why not just always call it before us? Why, like us putting it here or us leaving it out is really the same thing because it's going to get called either way, right? But there might be a case where we want to call a different constructor. So let me do this. Let me write, we're going to make 2 constructors. We're going to say outline equals black and fill equals white. And that's it. Now, what's another version of a constructor? Now what we want to do is we want to overload this method, the constructor. What if we wanted to give an X, a Y, an R, and a different color and a different fill color? So somebody goes to create a new, somebody wants to create a new, it would go, you know, it would get to the point where it says graphic circle equals new graphic circle. And then they'd start giving they'd give parameters like they want the X to be 2 and the Y to be -4 and the radius to be 3. And they would like the circle to be red, and they would like the fill to be yellow. So they call it like this. They say GC equals new graphic circle, and they give us 5 parameters. And then we have to go and create one with those instructions. Well, this constructor is no good because this one takes no parameters. We have to write another constructor. So how would we do that? We would say public graphic circle and now we're going to take in 5 parameters, and then we're all doubles, right, from before. So it would be double x, double y, double r, color, c. Yeah, this we kind of left. Should this be as?
This could be a string.
Well, then we probably should have defined colors as string. But if we made a set of colors that were just a subset of all string, like only red, orange, green, those are the only ones acceptable. String, we'd end up accepting anything. You could type in some word that's not a real color, and we'd end up taking it. So let's just say for now that we're taking a parameter of type color. No, I'm sorry. It's a. Oh yeah, it's the outline. Sorry. Okay. Color. O and color. F. Okay. So these are parameters to our constructor. Now, what do we do with them? Well, we already have in circle, we have another constructor, the circle constructor that takes 3 parameters, the x, the y, and the r. We already created that. So we can call that one and pass in these 3 parameters. How would we do that? How do we call the constructor of circle, the one with the 3 parameters? Now, this new keyword I'm talking about is super. That means call the constructor of the previous class, the superclass, and we're actually allowed to give it more parameters as long as that version exists. So we could do this. We could say super x, y, r. And the first thing that will happen is we take in this x, y, and r, and we send that to the method of the circle class. And it will fill in x with the x value, y with the y value, and r with the r value. And now the new stuff, the outline and the fill, we have to do ourselves. So that would be outline equals O, and fill equals F. So we now have 2 constructors for graphics. We have 2 constructors for a graphic circle. We have one that takes in no parameters. So if somebody wants to create a graphic circle and gives us no information, we're going to, what are we going to do? The first thing we're going to do is the compiler says, do I see a super here? And if the answer is no, you automatically call the super with no parameters. Even though we wrote three constructors for this, there's the one that takes no parameters. So if you forget, or you might forget on purpose, if the first thing you do in your constructor is to not call the superclass's constructor, they will automatically call it with no parameters. So in this case, we could have left it out because that's exactly what we want. We want the one with no parameters to get called. And what that does is fills in x with 0, y with 0, and r with a 1. And then we do black and white. The circle is black and the inside of the circle is white. Now we decided we wanted to have a different constructor because someone may come along and give us 5 pieces of information when they're constructing one of these items. They may give us the x, the y, the radius, the outline and the fill. So what we would then do is we would take the first 3 parameters, pass them into the constructor we created last class, the constructor we created for circle that takes 3 parameters. Pass them in and it'll fill in whatever this value was, this value and this value will get filled in for the x, y, and r. And now that we put this as our first line, a call to super, we don't get that automatic call to super with no parameters. So that's why it was actually, they made it an option instead of the compiler forcing it to be called, is because we may have constructors that are not the default constructor for this class, and we may want to explicitly call it. So we have the option to call it. If the first line of our constructor does not call one of the constructors of the super class, then by default this one comes in. So this one, I'll write it in a different color. Super with no parameters. That got put in automatically because we left it out. We could have wrote super, open paren, close paren, it would be exactly the same as not writing it. Because when you're doing a constructor, if the very first line is not a call to the constructor of what you're inheriting from, this will automatically be called. The one with no parameters will automatically be called. Is that the same in C#?
I'm sorry, what was that?
Do you call the this constructor of the previous, of what you're inheriting from by saying super?
I'm not sure that you can. What we usually do is, if the parent class has a property that you want to be made available,
Okay.
you give it a public getter setter,
Okay.
and then the child class can just automatically use that,
Okay.
which is like
And you call that method explicit.
base. Yeah. You just,
Okay.
So in other words, it would be graphic circle dot radius, as long as radius was publicly
Okay.
simpler.
Okay. All right. So now, in this case, we explicitly called a different version of the constructor for class. And unfortunately, I think it's less clear by using the word super. Well, super obviously means whatever the you have immediately inherited from, they better have a constructor that takes 3 parameters. If we were able to say this dot circle, I think it would be more clear. But then that would open the door to people calling constructors of classes much, much higher in the hierarchy. Okay, so does that make sense? That so what we're now talking about is inheritance, which means we're creating a class and we're kind of freeloading. We're saying extends in another class. Now all the work that was done for this class, we just get it all for free.
With the word extends, right?
Yeah, with the word extend. So it's like we're making a brand new class, and then it gives us the opportunity, we take all that stuff for free, we inherit it for free, and then we can add anything we want after it. Generally, the stuff we're adding makes it a more specific version of what it was before. So we're inheriting a circle, which is kind of a vague concept, and now we're making it more specific. We're saying it's meant for drawing. So this is a graphic circle, we're trying to draw with it. And so we have an outline and a fill. We could add more features like how thick is the outline, you know, how thick is the line, can it have multicolors, you know. We could make more classes below it if we wanted to. Okay. So now that we have this super setup and this idea that every time a constructor is called, every time your constructor starts running, if the first line isn't a call to the previous class's constructor, we'll call it explicitly. What happens if your class, let me erase this now. What happens if your class does not inherit from anything? So for example, our circle class didn't inherit from anything. But let me make an even simpler one. So once we have a class, point, which has point, and we had an int x and an int y. Do we have a constructor? Does this class have a constructor?
No.
Okay, so so, do we have to have, are we required to supply one? Or is it, like if somebody did this, if somebody came along and said, point P equals new, point, no parameters, what would happen? Okay, when you do a new of a point, it has two data fields, two integers. So we get a chunk of storage with an X and a Y. And then we run the constructor to fill this in with data. But we never defined one. So what would happen? Would this be a compiler error saying I can't find the constructor? Or would a default constructor run?
There'd just be no values for X and Y, right?
Yeah, well, they'd end up being whatever the defaults are for these primitive types. So it'd just be filled in with 0, 0, which might be okay with us. I mean, it's, what's a default point? What would you make X and Y? 0 and 0, right? So this is a case where where if we wanted to write a default constructor, we would go like this. It would be, the constructor is always the name of the class, so it would be point, no parameters, and then the method would be x equals 0, y equals 0. That's our default constructor. So if somebody ever made one and didn't provide any information, we'd fill it in with 0, 0. Lots of times you're okay with that. Where's an example where you're not okay with it? Let's say we wanted a ratio. Ratio, right? You know, a numerator and a denominator. We have a numerator and a denominator. If we don't supply a constructor and somebody goes and makes one of these, what's going to happen? We're going to get a numerator and a denominator. They're both going to be 0. Is that okay? It's almost exactly like the point, right? In both cases, this class had two integers. One was a point. We decided by default 0, 0 is the default point. What's a default ratio? A ratio is a numerator and a denominator.
1 to
1
1.
divided by 1?
0 or 1.
Well, you don't want the denominator to be.
Right, it's very important that denominator can't be 0. That's like a math thing. Now the compiler doesn't look at this word and go, oh, I know this can't be a 0. The compiler doesn't know what these things mean. We only know what it means, right? So the compiler doesn't care that it's putting a 0 here, but we know we don't want a 0. So what would be a definition of a default ratio? If somebody created a ratio and didn't tell you what the numerator or denominator is, and you're supposed to just fill it in, what would you fill it in with? 1 over 1, and I heard 0 over 1.
It's not like 1 over 1.
Either one of those.
I thought 0 over 1 makes more sense, because everything kind of defaults to 0.
If it starts at 0, that works.
Yeah, so it's legitimate, and we have a non-zero denominator. So now here's a situation where we kind of we're forced to overwrite the constructor, the default constructor. We got to do this. Ratio, no parameters, x is 0. What is the x? There's no x. N-U-N is 0. D-E 1. That's a default ratio. So here's a case where we couldn't get lazy. We had to supply a default ratio because we don't want people just accidentally creating 0 over 0 ratios.
Couldn't you just put int, like at the top there was this int num and then int denominator, could you just put an equal sign and give it the values right there?
Like equals 1?
Yeah.
So what we're
Are those usually private, those two variables up top?
yeah, one thing, we'll talk about access methods next class. You know, I've been writing public here, and then we're gonna have public, private, and protected, and that'll make a little more sense soon. But right now, even if we could get at these
So
fields,
the ratio that
It's like-
need that, but you didn't. So if they're.
right, in other words, what you're trying to do is you're trying to provide default values. Like, you know, why do we have to go and write a whole new method just to
Right,
supply all the
exactly, yeah.
default values if we can just kind of put them here? And then, like what you're saying is, we would obviously want to have a ratio where people can tell us what the numerator and denominator is. So we'd like to have another constructor like this. Ratio int n int d, and then, you know, num equals n, denom equals d. We'd also want to put in a check, like make sure the denominator doesn't equal zero. We'll probably want to do something like this. If someone gave us a 0 as a denominator, what would you want to do? Would you want to fail it or change it to 1?
We can make a check statement so that the user doesn't enter a zero.
If zero default to one or something.
Right. So what we'll do, and we'll talk about, did you go over exception handling last class? You did? Oh, okay, so you can handle, okay. We can handle this too. One is we can throw an exception here. We can say we don't accept 0. And the other thing we could,
We can also put like a while statement that until it's 0.
yeah.
While it's 0, then make this error statement until, like, otherwise it will go on.
Okay, but one quick and dirty thing we can do, we could just say if it's 0, make it a 1. Right? So, you know, so if somebody gives us like 100 divided by 0, we change it to 100 divided by 1. It's probably not what they want, but we could do this. If d equals 0, then d equals 1. And then we say denominator equals d. So we'll take anything you give us, but if you give us a 0, we're making it a 1. It's not the greatest thing in the world, but so here's an opportunity. So not only can we use constructors to fill in non-default fields, because like here's an example where we don't want the default. We want to make sure that the denominator is never 0. And then here's a case where the person is creating, the person is saying, you know, r equals new ratio, and they're saying 100 divided by 0. They're telling us what the numerator and denominator is, and we're copying it into numerator and denominator, and then we're saying, and we don't accept zeros. And we kind of have a little code here that handles that. So now the constructor can be used to handle special cases and to give non-default values. But then, okay, so now back to your question, why couldn't we just write them here? Suppose we wrote them here, and then here we are replacing them with different values. All right, we start them off with a 0 and a 1 and then change it if we need to. What that would do is it would eliminate the need for the no parameter version. Because instead, what we would put in the body of this code, we would just put right here.
But how would you call it if there's no constructor?
Well, no. So, like the idea is this: whenever you go to create an object, the first thing that happens before the constructor code runs, a chunk of storage is gotten for you for all the fields that are part of the class. Then the appropriate constructor runs where you could fill it in with non-default data. And it's optional because we might be happy with the default data. Like in the case of a point, 0, 0 is fine. But if we're not happy with the default data, then we have to write our own method to fill in the field. So I'm trying to think of a good example for why we can't explicitly set defaults. And I know in C++ they have an initialization list where you fill in all these fields initially before the constructors run. And if we were allowed to do this, we don't need this method because this and this should match. So we're kind of like filling in defaults and then saying, and if you don't like those, you can change it. with other men. Not really sure I have a good answer for why that is, but okay. So then, yeah, okay. So now, every time we create an object, we always call its superclass, whether we like it or not. It's going to, whether we explicitly called it or didn't call it. So now, suppose we go back to a class that does not extend anything. Well, let's go back to that simple class. Point. We have a class, point. Doesn't extend anything. So it's like it's the original class. And we decided it has an integer x and an integer y. Well, you know what? That means that we could allow floating points. Let's do this. Float x, float y. So we could have, you know, the x could be 2.5 or something like that. When the constructor for this is called, and we didn't give a constructor because we're happy with x is 0 and y is 0. We said that the very first thing that happens when a constructor is called is the superclass's constructor is called. This one doesn't have a superclass. We didn't say extends anything. It doesn't have a superclass. So if you were designing the language, what would you do in that case? Would you call no, you might think call no constructor, right? Because there is no constructor. But what Java did is they decided that every class in the world originally inherits from a class called object. They created a class called object, and it has some functions in it that are very, object is a really, like, I don't use the word abstract, but it's an abstract class. It means it could be any object there is. If you go and create a class called point, and you don't inherit from something, whether you realize it or not, you're inheriting from this class called object. So you really did this. Really did this. And before we had circle and then graphic circle. So what we really did was this. So what I'm saying is, when we created the first class called circle, we didn't inherit from anything. Well, whether you realize it or not, you inherited from this original class called object. Everything originally inherits from object. So, by default. So what's really happening in this class case, you have a constructor that looks like this, that you got for free. I'll write it in green because you didn't have to write it and yet it's still there. Point, no parameters, super, x equals 0, y equals 0. You got this constructor for free without even writing it. You always get for free a constructor that takes in no parameters, immediately calls super, whether there's a super or not, because now apparently everything has a super. Because this class they created called object, every class you ever create, you either inherit from something, and if you don't, you inherit from object. And if you inherit from something, that something must have eventually got it from object. Because originally, the first class you ever created had to inherit from nothing. And then you could start inheriting from those things, but the original one you wrote had to create from object. So this constructor, this is what they'll call a default constructor. If you don't supply one, you get this for free. You call super with no parameters, and then all your fields get filled in with default data.